So here's the deal. Over the last week or so, we learned about different forms of linear equations. Linear meaning line, equation meaning equal sign, right? So here's one of the forms. What form is this? Slope-intercept. How do you know it's slope-intercept? Yeah, it has the slope. And it has the y-intercept, right? What is slope? Rise over run. What is rise? Yeah, it's distance, right? How much we changed vertically. It's subtraction because it's distance. How much we traveled up and down. Hi. It's not working so well for you. Try something different, okay? What are you doing?
Oh, I was seeing my mom texted me.
Gotcha. Yeah, check later. Say hi for me. Rise over run is this, because rise is how much distance we traveled vertically. Vertical is y values. Run is x values, because it's left to right. Of course it is, right? We also know that this is the change vertically and the change horizontally, yeah? That's slope. How much we changed between 2 points, right? How much we did up and down, how much we did left and right. That's the idea. So this is slope. What's a y-intercept? What is it? What does it mean? What is a y-intercept? Where the line crosses the y-axis. Crosses. It's where it crosses the y-axis. So here's a coordinate plane, and here's a line. Where it crosses the y-axis is the y-intercept. This is the y-axis because up and down is y, and left to right is x. Duh. Right? So where it crosses the y-axis is the y-intercept. So if the y-intercept here was a 2, that means, hey, look, it crosses at 2. That's the idea. It gets us a free point. That's what's nice about this. And then we could use our slope to find another one. So far, so good? Yeah. Give me an example of a y-intercept. Give me a coordinate that would be a y-intercept. Negative 3, 4. Is negative 3, 4 going to be a y-intercept? Why not? Negative 3, 4 is here. Is that a y-intercept? Can't be ever, right? Give me a coordinates 0, 4. 0 in the x direction, 4 in the y direction. 1, 2, 3, 4. That's a y-intercept. Give me another example of a y-intercept. 0, negative 2. What do all y-intercepts have in common? 0 for the x, of course, because they're somewhere up and down, but they're nowhere left and right. Ah, right? Starting to come back to you? Awesome. Let's talk about another form of the linear equation. Again, it's the same dumb crap. It's going to be a line. It's just another way to write it, another way to look at it. Let's do it this way. This one. What does M stand for? Slope. Parlez-vous français? What are H and K? They're a point. What do we call this form? What do we call this form? Point slope form. Why do they call it point slope form? Because it gives you a point and the slope. A point that's on the line and a slope. Okay. Notice H and K are negative up here but positive down here, meaning that the signs are different, right? So whatever the signs are here, the point signs are going to be different. H comes before K in the alphabet, X, Y, pair. This one's harder. Here's another form of a line, another way to write an equation of a line. Yeah, let's not do that.
Yeah, no thanks. Why? What's the difference?
Lowercase b is y-intercept, lowercase a is x-intercept. These aren't intercepts. So, I mean, this form right here is called standard form. It's where x and y are on the same side and they equal a number. A, b, and c are numbers. We call it standard form because it just looks nice. It's not the form we use the most. That's y equals mx plus b, right? We use that one a lot. This is standard form. Why is standard form useful? Because if I give you an equation like this, give me a number for b. I'm writing on the gap. 4. Give me a number for c. Great idea. So, What's useful about standard form is we can easily find x and y-intercepts. What do all y-intercepts have in common? 0 for the x. So I'm looking for a y-intercept. I know that x has to be 0, right? That goes away. Y has to be what? 3, because we divide by 4. So 0, 3 is the y-intercept. What if I want to find the x-intercept? All x-intercepts have 0 for y, because they're somewhere on the x-axis, but nowhere up and down. So 0 here. What's 0 times 4? So again, it goes away. What does x have to be? It has to be 4. How many points do you need to graph a line? I have my 2 points. There it is. Super easy to graph. Might even be easier than y equals mx plus b. All right? So you get your intercepts for free. Last thing, and then we're caught up. Yes, this is review. Two equations with a little squiggly bracket says that they're in a system of equations. It means that this y is the same as this y. I want to know what solution they share, right? This guy's going to have a line, this guy's going to have a line. Where do they intersect is what I'm asking. Because where they intersect is where they agree, right? So how do I figure out where these intersect? Well, I have a couple ways. One, I can graph them, see where they intersect, right? We know how to do that. Y-intercept at 1, go up 2 over 1. Y-intercept at -4, go down 3 over 1, right? See where they intersect. Yuck. Or I can do it algebraically. If this equals y and this equals y, don't they equal each other?
Yeah.
Right? If I told you 3 plus 5 equals 8 and 4 plus 4 equals 8, doesn't that mean 3 plus 5 should equal 4 plus 4? This junk equals y. This junk equals y. Well, then they equal each other, right? Are you smelling what I'm stepping in? So 2x plus 1 should equal -3x minus 4. Where do they equal each other is what I'm asking. I have one equation with one kind of variable, so I can solve that. Let's get our x's together. Terrible idea in real life, great idea in math. I'm going to add 3x over to this side and I get 5x. I'm going to subtract 1 over to this side and I get -5. Are you with me? I did a lot at once. I added the 3x over. I subtracted the 1 over. What do I do to separate the 5 from the x? Divide everything by 5, which is really easy. So they intersect at -1 for the x. But where do they intersect vertically? I need to figure that out. I'm going to plug in -1 into one of my equations, and it's going to tell me what y is, right? Isn't that what this says? You times x by 2 and add 1, it gives you y. Well, we know x is -1, where they intersect. What's 2 times -1? -2, add 1. -1. So they intersect at -1, -1.
That's crazy, bro.
That's where they agree. That is the solution to the system. That's where they both agree. A single line has infinitely many solutions because, look, there's a solution, there's a solution, there's a solution. Any of these points, right? They all work in the equation. 3, 4, whatever, right? Where they agree is where the two lines share a solution. And that's what we're finding. We can do it graphically by seeing where they intersect. Or we can do it by this. We call this substitution. Everybody say substitution. Good, awesome. Say orgy schmorgy. Very good. So, substitution is switching out stuff. That's what it means, right? When I'm gone, I have a substitute. We're basically the same. They're interchangeable, right? Yeah. So, check it out. This equation says that y is this. If I told you y is 5, couldn't you plug in 5 down here? Right? Yeah. Right? You do it all the time. But if I tell you y is this, why not take this and plug it in down here? We did. They're the same thing. This is y, so switch them out. They're the same dumb crap. They're interchangeable. Just like me and a substitute. Nevaeh is laughing. and I don't know why. So they're the same thing. So we call this substitution, solving by substitution, solving by subs. You switch them out and plug them in. Then you figure out where they intersect. Now, this is really convenient because this system of equations that I gave you already has y on its own, right?
Yeah.
But what if it ain't?
Oh, that's.
Then get it on its own. Here we go. Now you may take out a piece of paper and play along. What?
I got my piece of paper.
Yes, you may. Here's your system of equations. Yes?
Can you slide it up too?
Oh.
Yeah. Hey,
Nice catch. Here's your system of equations. You may follow along at home if you wish. I'm just making these up. Yes, it would be really easy to find X and Y-intercepts. That's all I'm asking about. I'm asking, where do these two lines intersect? In other words, what's the solution that works for both of these guys? So what we need to do is get either Y or X on its own, and then we can substitute. Because if I have Y on its own, like I did here, I know this is Y. So wherever I see Y, I can switch this out. Which equation do you want to mess with? Top or bottom? Top? Okay. Let's take the top equation. What variable do you want to get on its own, X or Y? I ask the questions. Y works. All right, so I'm going to move the 3x over. How do I move 3x?
Divide that.
No, when we move stuff, we either add or subtract. We're moving the whole thing. So we subtract it over. We leave the negative 5y. We subtracted 3x, so now it's negative. And there was a positive 15 already there. How do I separate the negative 5 from the y? Divide everything by negative 5. So we get y equals, two negatives dividing makes a positive, yeah? What's 3 divided by 5? 3/5. Fractions are division for lazy people. What's 15 divided by negative 5? What's going to be negative, right? It's going to be 3. Okay, so y equals all this junk. Also, we just happen to get it in y equals mx plus b form, right? So all of this is what y is. Now, I'm not going to plug it back into the original thing, okay? And here's why. I'm going to use a metaphor. Because mathematically, I can explain it, but none of you care, okay?
Don't.
I see the inside of your closet.
All right? Here's what y is. See, it's the blue equation is how we got it. If I plug it back into the original, it's like doing this. Why isn't it working, right? Don't do that. You'll get a feedback loop. What'll happen is you'll get 0 equals 0 or negative 2 equals negative 2 or 5 equals 5, right? That's not what we want. Here's what we're going to do. We're going to plug it into the other equation. Where are we going to plug this in? In the bottom equation. What are we going to switch out? What are we going to substitute? We're going to substitute what for this? We're going to substitute y for this. This is going to go where y is, because that's what y is. If I told you y was 2, couldn't you plug in 2 here? I'll say it again. If I told you y equals 2, couldn't you plug in 2 here? You can plug this in too. It's not. Negative 2x plus 6 times whatever y is. Whenever we plug stuff in, we wrap it in parentheses, right? No matter where we plug it in, no matter what we plug it in. And the reason we do this is for safety. Notice that if we didn't do parentheses, you probably wouldn't notice that we have to distribute that 6, right? You got to distribute the 6. It's got to be in parentheses. Whenever you plug stuff in, wrap it in parentheses. You're going to make mistakes like that on Friday. Don't let it be you. Okay? Don't be a statistic. Negative 2x. The 6 is going to get distributed. Let's do it. 6 times 3 divided by 5. What's 6 times 3?
18.
18 divided by 5. 18 over 5. What's 6 times negative 3? Well, first of all, it's going to be negative. 6 times 3 is 18. I'm going to add 18 to this side. 6. No, it's okay. I added 18. I got 6. We're going to get our x's together. What do we need to add those together?
Addition. Wait,
What do we need to be able to add them together?
Common
Common denominators, right? This one's over 1, that one's over 5. They're not the same. It's apples to oranges.
Make it 5.
How many fifths are in the number 2?
10. You guys are real smart.
Now, there's 10 fifths in the number 2. If you're not sure, think of it in your head. Is 10 divided by 5 still 2? Yes, so we didn't change the problem. I'm going to say it again. 10 divided by 5 is still 2, right? Troy, 10 divided by 5 is still 2, right?
Yeah.
So we didn't change the problem, we just made it look different. And the reason we made it look different is so now we can see how to add these together. Negative 10 fifths plus 18 fifths. 8 fifths. Multiply by the reciprocal, right? So we're going to multiply by 5 and divide by 8. What's 6 times 5?
6 times 5 is 30.
Divide by 8.
No, I don't remember. 30 over 8. 15 over 4.
They intersect at 15 over 4 for x. Now we're going to plug that back into any of our equations, because that's the shared solution, right? It works for either or. And we're going to find out what y is. Right here. Which equation do we want to plug it into, top or bottom?
Top.
Okay? So when I plug it in here,
Oh, it's
when I plug it in, I wrap it in parentheses, yeah? Let's do the math in our heads.
Is that a 15?
That is a 15 over 4, yeah.
That's the same. Throw it away. Are you using Ethan?
All right. 3 times 15. Pause. If you don't know it, that's okay. What's 3 times 10? What's 3 times 5? Add them together. 45 over 4 is what we have here.
Divided by nothing.
Are we back?
Yes.
So we plug this in, we got 45 over 4 minus 5y. We're going to subtract 45 over 4. So I get negative 5y equals 15 minus 45 over 4. What do I need to do to subtract these?
Common denominator.
Yeah. Yes, Gian. Troy, stop making that noise, please. What do I need to do to subtract these? Common denominators. How many fourths are in 15?
Too many.
How many fourths are in 10? 40. How many fourths are in 5? So 60 fourths. Is 60 divided by 4 15? Think about it. What's 60 divided by 2? Divide by 2 again. 15, right? Dividing by 2 twice is the same thing as dividing by 4. Yep. How many fourths do I have now? 60 minus 45. Come on. 15 fourths. Now, how do I separate the negative 5 from the y? Divide. It's okay. Think about it. First of all, we have a positive number divided by a negative, so it's going to be?
Negative.
What's 15 divided by negative 5?
3. Negative.
And then we divide it by 4, right?
Yeah. That was dang, bro. That's why.
That's where they intersect. That's as hard as it gets. That's the hardest it can possibly be.
So why'd you make it that way?
That way you know what you're up against. So here's what we did. Again, seems like a lot of stuff. Let me break down what we actually did. First off, we chose a variable to get on its own. We chose the top equation's y. So we took the top equation, we got y on its own. Then we took what y is, and we plugged it into the other equation, right? We're not going to plug it into the original, right? So, we took this and plugged it in here. Do I have your attention now? Do I have to hurt myself every time? Okay. Thank you. So,
If you would have missed, that was
I know. The things we do. All right, so I plugged this in for y. When we plug it in, we wrap it. We do math, and we find out that x is this. It's gross, but again, this is the hardest it can get, right? So that's what x is. Now to go find y, I take that and I plug it into the original equation, either or, and I do math and I get y. How do you feel about the ideas? It's not too many steps. Concepts. Think about what we're doing here. We're trying to find out where these two equations agree. So what we're trying to do first, again, watch as we go through it again. We took our original equations. We picked one. We picked the top. We're going to get one of the variables on its own. We chose y. So we took the top equation, and we got y on its own. We found out that y is this. Because that's how the math worked out. It's math. Who cares? Y is this. Then we took this. Hey, I'm going over it again because you don't know it. So shut up and learn. So I took this, and I plugged it back in. Not to the same equation, but a different one. When I plug it in, I get this. Wrap it in parentheses when you plug it in. Do math. We get that x is this. Cool. Then we take x and plug it back into either equation. We chose the top one. And then we do math and find out what y is. Again, in faster motion this time. Pick an equation, get one of the variables on its own, plug in for that variable in the other equation, do math, get x. After you get x, plug it back in and get y.
You remind me of that family guy.
How do you feel about the concept? That's as hard as it can get. That's substitution. I know. Get a piece of paper. This one's for you guys to do. Get a piece of paper. This is for you to do. Yes.
I don't think you're taking care of Leonard very good.
He's doing okay.
He has a piece of paper in him.
Yeah, I know.
He's kind of dying. Like, low-key, he's dying. Is he okay? It's dying.
I will in a second. Get your piece of paper.
I'm just gonna get one.
A couple ways I can ask this question. I can ask, where do these two lines intersect? Which is the same question as saying, what's the solution to this system? What? No. They won't be until the absolute end. And if scenario A, I don't get you them in time for you to check to see how many you have, then that's on me and everybody's good. Scenario B, I get them to you ahead of time and you're fine, right? So it's going to be fine. Either way. Don't worry about it. I got it. We might not get them. It happens. If you've ever been in to see me to ask questions, you have more, everyone's going to be fine. Okay? Don't worry about it. Find out where these two equations intersect. This one is easier than the one we just did.
Look at that.
Beautiful. No.
Are you jealous?
Answer will be whole numbers.
Definitely.
Integers. Let me clarify. Integers. Answer will be integers.
You see that new episode of Rick and Morty?
What?
You see the new episode of Rick and Morty?
I did not. No.
Oh, man.
Oh, come on.
Is it good?
Yes. It was
I'll check it out.
It was good.
I haven't watched that in years. Last time the season came out, I was teaching in Sandwich. It's like 3 years ago.
Wasp Rick.
No, it'll be integers.
Racist. Fastest.
You did not be typo.
Yeah.
How do you say it?
Same side.
Fascist.
I'm sorry. The bear was my favorite.
Yeah, teddy bear Rick.
It's like just straight up. Just like, but no. Honestly,
I have not a clue what I did wrong. I did
you guys meant to just go.
I put in
Teddy bear.
before X plus 2 for Y.
Like knowing that that existed.
Yeah, so you're right. 0 divided by 18 is just 0.
Oh, so
It's 0, yeah. You have 0 things and 18 friends. Everybody gets nothing, right?
I kind of stopped thinking about this rationally.
What is 0 divided by 18? Nothing, right? So it's 0.
Wait, what's zero?
Great question. You know, so Nevaeh, you know that coordinates are points on the line, right? And points on the line are numbers that work the equation, meaning that 0 for x should get you something for y, right? So how do we figure out what y is? If we know what x is 0. How do we figure out what y will be? So you know x is 0. Do you have anything up here that tells you what y is going to be? I'm asking the same question in different ways, trying to get you to think differently. If you can't, that's okay. It's a really simple thing. I just want to see if you can figure it out. If you can't, it's just you're not seeing it. If I plug in 0 here, don't I get y? Right, that's it. Yeah. Right, I can plug in 2 here and get what y is when x is 2. Right, that's what a coordinate is. Double check your work. Not 0, not that. Double check your work.
Oh my god. Black bear.
He's so thick. Well, he's kind of thick.
Yeah.
Oh my god. Oh,
Well, we'll figure out what the line So if I can do y with 2, we can plug in 2. No. You've been zoned now.
she was supposed to be out Monday one time and then Wednesday,
Where's she? She's in there.
but I don't know.
Okay. You were checking your notes here. So, we figure out what y is, right? And we take that and plug it in the other equation.
But she's okay right now.
I don't even know what happened. I just knew that she wasn't here.
It's easier than that. It's already easier to start any work to get
She
y.
was supposed to come back Wednesday.
Yeah.
Wow, that was easy.
You know, she's not gonna be back. If at all. And if she does, or like when she does get out, she'll probably be here.
What'd you do?
I mean, she's okay right now. She just can't wait to get out.
Wait, can you get 0 divided by a number?
Yes, you can.
Yeah, that's not mine.
Yeah.
And then she
Yes. All right, I'm going to show you how I did it, and you're going to catch where you got stumped. No.
I'm not done.
I know, but you can compare your answer to mine. So, 0 divided by anything is 0. Just so you know. So here's how I would have done it. You could have gotten y on its own in the top. You could have said, look, I'm going to get that negative 2x over. I'm going to get that negative 2x over and then divide by 5. You could have done that. But guess what? Y is already on its own. So I'm going to take this and plug it in there. So here's what I do. I take the top equation. I'm going to plug in for y. Nope, different way. You could have done it a different way. How'd you know y equals 2? Are you talking about the Y-intercept? That's not what we're looking for here. We're looking for where they intersect. We're not looking for 2 points on the line. All right, so we distribute the 5. And we get negative 2x plus 20x plus 10 equals 10. Get our x's together. How many x's do I have on this side? 18x. Subtract 10, I get 0. What's 0 divided by 18? So x is 0. First of all, if x is 0, what kind of coordinate is this? It's a y-intercept. What's our y-intercept here? 2. So they intersect with the y-intercept. Now, that's just me being clever. But if you plugged in 0 here, what do you get? 2, right? So they intersect at 0, 2. Baker. We plugged it in. We distributed. We did math. We got 0. And then we plugged it in and got 2. Cool? All right. Yes. That's substitution. Switching stuff out. Next one. You have to. Haha. Yep, that's right. Yes. Yes. Let me think.
That's like
Like an inverted one. Yeah. Like inverted, like on the outside.
shouldn't be going on the inside.
No, like.
What's the top one? Is this going to be whole numbers again?
Yes.
Yeah.
Integers.
Round it in.
Yeah. And then
Meaning that it can be positive or negative whole numbers, right?
I've never seen one like that.
Because this is like a 10.
Again, we are not looking for X and Y-intercepts. Could you find them if you wanted to? Sure. Plug in 0, see what happened, right? Close. Close the bucket, but not the recycling.
Oh.
I got you. Sit down.
I think it's fine.
And then just. Yeah.
Yeah, you're not going to do that. So go sit down.
You know that, right?
Huh?
You know he's recording.
No, I don't. Oh,
What? No, don't do that.
I remember that time.
I don't care if you use it at home or for homework.
And then
I don't care if you use it.
video and I can hear.
I don't care if you use it for homework and stuff. It's fine. But like, how's that going to work out for you? Right, exactly, right?
I'll get used to homework for homework. I was
Like, please do that. That way I can give you hundreds on the homework and not have to grade anything. And then you fail the test, and then I put in hundreds for homework, which is really easy to put in, and then I get zeros for tests, which is super easy to put in. Like, please, like, come on, right? Knock yourself out, literally.
Okay. Like, can I just fall asleep? You said knock yourself out.
Yes, you're not able to learn. You should fall asleep and get to where you are able to learn. Here's the deal. You keep doing that, and it's yourself. So you do you. Well, pick a variable we get on its own. Okay? Pick an equation you get on that you're going to get. Top or bottom choice. Well, if you plug it in, check your answer. Guys, to check your answer, take your coordinate and plug it in. Maybe you think 3, 1 is the answer. Well, then you plug in 3 here and get 15. Plug in 1 here and get minus 3. Is 15 minus 3, 10? No, then you goof. 3, 1 isn't the answer, right? Try the combination that you found, right? It's like a lock. Yeah, go. You got x on its own, so you chose the top equation. You added 3 divided by 5, which means you get, what? No, okay, no, you added 3y over the top, and then divided by 5. Good. Yes, that's what x is.
Alright.
How's it going?
Me?
Yeah.
I don't know.
Great start. Pick a variable together on its own. And then once you have that variable on its own, plug it together.
I'm better at
Yeah, it's just that easy. You gotta get one of them on their own. So which equation do you want to mess with, top or bottom? Okay. So you want to get x on its own or y on its
I don't
own?
know how I played last,
Okay. So move over the 2x, right? Divide by -4 eventually. Now here's the thing. You know you're going to have to divide by -4. Is 10 going to divide nicely? It's not. So if you get x, so if you get x on its own, right? That means you're going to move that over, right? Divide by 2. Because everything goes by 2. Yeah. So it'd be easier to get x on its own, wouldn't it?
Okay.
Right? You can do either, but like, pro tip.
I'm lost. I don't know what to do.
Yes. 0, 0. What's up, Tucker? So did you plug it back into itself?
Dad.
Why? Yeah, don't do that. Yeah, you have to plug it into a different equation.
How's Jason?
Yeah, if you like 0 equals 0, or 2 equals 2, or 5 equals 5, you probably plugged it back into itself.
I'm probably
Does that help?
I don't know. Y'all just bumping the banana apart.
We're not doing anything.
I think that's a lie. You got this kid on Snapchat? Every day, him and Jason, man. Every day.
It's just the muse.
It's literally every day.
Why are you looking at you're looking for the X-Intercept?
Every time they work.
Okay.
We're looking for where they are. Yes.
Both not really related. Because both kind of just got out of one around the same time. That kind of works so far.
But you're still bumping it.
No.
So, how did you get her? That's a real question.
I don't know.
How did that happen?
I guess I'm just a nice guy.
That don't mean nothing.
No, I'm telling you right now.
Dude, you look like a lumberjack. Whoever's watching this probably like, yeah, you're right.
Dr. Brown?
Do you think it looks like a lumberjack?
No. I mean, lumberjacks can look like anybody.
He
No.
looks like he would.
I meant like the ones that are like flapjack.
Like we're all like the. Like I don't think you understand how many guys look like you there. They all look the same.
I just want to know how it. I'm an asterisk.
Tucker looks like a hockey player. That's right, you got the flow.
There's only one black hockey player. You know that?
That's not true.
One black hockey player
There are lots of black hockey players. I can name at least 3
in the NHL. Right?
in the NHL right now. Malcolm Subban, goalie. I can name a defenseman, Dustin Bufflin. And I can name a forward, Evander Kane.
I don't like hockey.
All they all look alike.
Yeah. Like, first of all, like, you'd think Canadians are like the #1 players of hockey, right? But like French Canada, Quebec, has a large black population.
So like black people.
I mean, love.
They're like in every sport. They outnumber.
Although the 3 that I mentioned, only one of which is French Canadian. Malcolm Subban's brother also plays, Jordan Subban. And then, most famously, PK Subban, his oldest brother, he plays as well. All right, so here we go. Here's what I would do. I'm going to pick the bottom equation, and here's why. Here's why I'm going to pick the bottom equation. If I get x on its own, I'm going to have to divide by 2 eventually, right?
It says 33.
All right, shut up and watch. So, I'm going to pick the bottom equation. The reason I'm doing that is because if I get x on its own, I know I have to divide by 2 eventually. Does everything divide by 2 nicely here? It does. If I try to get y on its own, that's valid, but you have to divide by -4, which isn't going to be nice, right? So I'm going to choose this one. And I'm going to do this. I'm going to divide by 2 to start. You can divide first. PEMDAS is a lie. Just do it to everything. And then we get this, x equals 2y minus 5. I'm going to take that and plug it into the other equation. 5 times 2y minus 5 minus 3y equals 10. Distribute. Don't worry about copying this down. You're not turning it in. Watch and learn. Copying it down has no. That won't help. It won't. So y is 5. If y is 5, plug it in. -15. We add the -15 over to make 25. 5 times 1 is 25. 5 is the answer. All right, kids. Do we agree up to here? I divide everything by 2. Do we agree up to here? Do we agree that I plug it in and I get this? Do we agree about the distribution? Do we get 10y minus 3y is 7y? Do we get that adding 25 over makes 35? Y equals 5. Plug 5 into any of them. -20, add it. I get positive 10. X must be 5. That's substitution. That's as hard as it gets.
So it's only gonna get easier from here.
I mean, we're learning other stuff, but like for that particular type of problem, that's as hard as it gets.
So you won't. Sounds like Maggie.
What?
I held on to it.
See you tomorrow.
Right.